just picked clever colors.
So this is bluish because blue is the Z and Z is the one that you have
Yeah,
from.
so blue is how much of the normal.
So a perfect sphere could have completely blue.
Yeah, a perfect sphere would have completely blue normal. And if you look at other textures, like the sun, sorry, not the sun is not Earth. But here's a great example. That's the cloud map, transparency map, which I didn't get to use. But the Earth bump map is a lot more understandable. So you can see the mountain ranges there very well. You can see their contour. Yeah.
Any more questions? Yeah.
Just out of curiosity, how much time actually went into this? Because I remember seeing you working on this on like the first day of class.
Yeah. Yeah.
Well, I worked on it. Well, from the graphics side, I worked on it for probably about 4 weeks at the start of classes and probably the last 4 weeks. But that's like I said, I had a really like course load, so that's like the full 4 weeks of working on it and like nothing else.
Yeah.
Yeah.
So obviously there's probably a lot of light computations going on for like the bump maps and stuff. How'd you keep the performance so well? Or so good?
Okay, well, the way the geometry is stored actually is there's just one object. Where's this mine? No, it's not. Oh, that's mine. Oops. Not used to Windows 8 98. I have this one create sphere function that you specify latitude bands and longitude bands. I initialize it to 50, I think. Oh, did I lose it? Was it there?
Yeah, I think so. But yeah, it was 50.
Oh yeah, right there, 1550. So I have the one sphere, and every time. Let's just close these things. A lot easier. Yeah, this is actually how everything happens. Well, the callbacks only have one. You can associate one per planet, but there's only one that's in use, and that's for the sun. And what it does is, on the radial blur texture, if your camera is such that your sun is here in 2D space, then your radial blur needs to start from this point. It cannot start from this point. Otherwise, you have just a weird sun shaft that goes in that direction. So that's one thing. And then after that, instancing, which is actually what one thing that he did, is where you draw everything in black. Oh no, that's not the one. This is the one where you draw everything in unique colors and you sample the pixel where you click to find out what you clicked. Then the skybox, once again, we did that. It's pretty simple. It's just the cube, right?
Yeah, it's just a huge cube. I think it's
a really, really large cube.
I can't remember if it's 100 times 100 times 100 or
Yeah.
something like that.
And just has the star texture.
Is it a cube texture map you used, or did you use 2D textures on all sides?
It's just a single square texture that's used on each side of the cube.
Oh, okay.
It's a 3D cube. It's just really big. You can technically move outside of it.
Oh.
Yeah.
Well, no, I made it so you can. You don't move in the center.
Oh, okay, yeah, yeah.
You can rotate the camera around and see the different sides of it, but you can't move out of the skybox.
So I guess, yeah, move the cube. Oh yeah, I remember we talked about that. There was a small technicality where you don't move inside the cube, you move the cube to you, but it doesn't matter because we only have the one cube in the skybox. There's no like other objects. So it's the same whether you move to the cube or the cube moves to you. Implementation detail. Yeah. So then that's a skybox, which just draws basically the background. Interesting side note, because this is a skybox, you don't need to clear the color buffer, because everything, by default, everything will be covered by skybox, and then you draw the planets on top of it. So it's just one small optimization there. And then the draw sphere is almost everything, and it's right. Yeah, this is draw sphere right here. So I actually had four different shaders. One for the sun because nothing happens to it. It's not even lit. It's just always 100% lit because that's where the light comes from. And one for all the gas planets because they only had texture and diffuse lighting. One for all the terrestrial planets because they had diffuse lighting and bump mapping. And one for the Earth because it had a ridiculous amount of things going on. And every time you go through, this is just a code to find out what the shader uses so you can set the proper uniforms. I use standard names for the uniforms, so a lot of this code looks a lot like set point of view. Because I know that every shader I wrote uses all the same uniform names for the point of view uniforms, I don't need to set, like to use specific strings. Everything's set. Nice, conveniently named functions. Makes the code look very pretty. And at the end, what happens? You pass the planet, which actually hold its own normals. Sorry, not normals, but the transform and the sphere. And so basically, you pass this one piece of geometry to multiple different textures associated to it, multiple different model view matrices, multiple different shaders, but always just the one piece of geometry. So is it 5,000?
Yeah, it's 5,000 tries
Yeah.
per planet.
With 50 by 50, it's 5,000 tries per planet. But you don't see a whole lot of overhead just because you only have the one piece of geometry and it's being used over and over again. Or for the effect, I don't believe we covered this in class, but for the effect, what actually happens for the sun is you have this buffer where you actually draw your planets. Sun, and you have the planet here and the glare. But before the glare is applied, you have an alternate texture where you draw the occlusion map with that just the sun, and you use this, you blur this, and then you'd use an additive blend here. That's how it works. You use two separate textures.
Any more questions?
One last thing, could we just quickly look at the shader you wrote for Earth?
Yeah. It was actually really ugly before I separated them all into, oh wait, the wrong one. It was very ugly before I separated them into multiple shaders because like I said, there was just so many conditionals. So yeah, there's two different vertex shaders that I use. A simple one which just sets the position, and this one which propagates the position, normal, and texture coordinates. And then, as you can see, this is the sun, tiny little thing, compared to the Earth, which is all this. And conveniently separated, these are all the varying, all the uniforms, a few constants, most of which I never even used. And then I take texture samples, and actually this is what I was talking about, the magenta. If you don't run it off a server, or if you don't allow local file access, every color has a fallback. The fallback for the normal texture is just to not have bumping, because this is how much of the usual normal you use. But anyway. Yeah, so here you're sampling all the four textures. Here you're get the normal, you create a tangent as a cross product. I think I said dot product a couple of times before, it's actually a cross product. Cross product of the normal and the up and then you take the cross product of the normal and the tangent you just created. And that creates a little system right at the vertex that you are, not the vertex, but the fragment you're rendering. And then you use, well, just for technical reasons, negative x times the tangent, negative y times the bitangent, and positive z times the normal. And that gives you your final normal. And I actually noticed that when I was generating the normal maps, I used options because when I looked at the texture that's mostly blue, it looked like if you couldn't really see the hills, and I thought, well, that's not good, so I changed the options to make them more apparent. But after rendering it, I now notice that sometimes the hills will be lit in white even if they're behind the earth. That's because that's how much the normal was changed. It is way too much. No, I'm sorry. Yeah.
Any more questions?
Diffuse and specular fragment color.